Hello everyone, in this video I am going to show you why and how we can simulate and plot the Illuminance distribution in LED light-based visible light communication system using MATLAB. But before delving into MATLAB coding, let me explain why we simulate Illuminance distribution and its significance in achieving good communication performance in a specific geographic dimension. Basically, the main objective in evaluating Illuminance distribution is to observe the spread of light across the specific area, and it is important to ensure uniform brightness and equal distribution across the room space, because if we place LEDs without carefully identifying their position, we may have a different illuminance levels at different position in the room, and if the signal doesn't reach a specific location just because of poor lighting, then it is considered a poor planning and deployment, and it will greatly affect the user experience. For example, in a room, let's assume a size of 5 by 5 by 3 in meters, where n number of LEDs are installed on the ceiling and each has specific position, and position of each LED can be given by Cartesian coordinate system, such as if we say LED 1 is located at 4 by 3 by 3 and LED 2 is located at 2 by 3 by 3. Now here 2 represents the x-axis coordinate, while 3 is the point on y-axis, and then 3 is the point on z-axis, which corresponds to the height of the room. So this is how we simulate the system before deploying it in a real environment. This simulation greatly helps in analyzing different parameters and assessing the performance of the system before it is actually installed in the room. Now let me show you how we code in the MATLAB. Let's assign the values to the parameters, such as our half-power semi-angle is theta equals 60 degrees. Then the Lambertian order can be calculated as m equals log 10 2 / log 10 cost theta. Then let's say our room dimension is 5 by 5 by 3 in meters and LED 1 is located at 2.5 by 2.5 by 3. Then it means our LED is located at the center of the room, right? Okay, now the most important factor in simulation is grid spacing. What does mean by grid spacing is step size of my x and y coordinates, such as x is equal to 0:0.1:5 and y is equal to 0:0.1:5. Here 0 is my starting point on x and y axis, and then 0.1 is the step size. Like calculate illuminance value after every 0.1 step up to 5, which is my maximum y axis value.
Choosing a smaller step size such as 0.001 or an even smaller value improves the resolution and helps capture very small variations, which is essential for detecting peaks and dim spots and for accurately understanding the level of illuminance at each point along the x, y, and z axes.
Now we use a mesh grid command in MATLAB, which returns a 2D coordinates based on the coordinates contained in x and y, and the syntax of mesh grid is given as. Here capital X is a matrix where each row is a copy of small x, and capital Y is a matrix where each column is a copy of small y.
Now the light intensity distribution, that is illuminance distribution, can be calculated as follows. Where L is the luminous flux of the LED measured in lumens, but there are other ways to express light intensity, such as candela CD or lux LX, so whichever unit system is used should be converted or adopted according to your requirements. And M is the Lambertian order. Cos phi represents angle of irradiance, while cos psi represents angle of incidence at the receiver, where a light receiving photodiode or camera-based technology is used to capture the light intensity and the received signal, and the term d in the denominator denotes the Euclidean distance between the transmitter and receiver.
To calculate the angle of irradiance, the following formula can be used, and here arc cos denotes the inverse cosine function, and xt, yt, and zt transmitter 3D coordinates, while x are y are and z are our receiver 3D coordinates. To calculate the angle of incidence at the receiver's orientation must be taken into account, as it can be oriented in any direction. Although the orientation of the LED can also be considered, but in most practical scenarios LEDs are oriented in a fixed direction and distribute light uniformly within a specific beam angle, like beam lobe. For example, an LED mounted on the ceiling typically directs light straight toward the floor. If the LED orientation is to be included, it can be incorporated by multiplying the LED orientation unit vector in the equation when calculating the irradiance angle. And the equation can be formulated as This formula is simply derived from the dot product of two vectors, that is our LED and a receiver, with the associated receiver orientation, where Vn is the receiver orientation unit vector with transpose T, and multiply with the dot product of LED and a receiver position and then divide by their magnitudes. We have gone through all the equations and parameters, so now let's move on to the MATLAB part to see the Illuminance distribution. Okay, I am sharing screenshots of the MATLAB code along with comments so that you can read and understand it easily. This will save time instead of writing out the code step by step. If you have any questions about any part of the code, you can comment directly and I will respond as soon as possible.